Okay, finally today, everyone start crying. Our very last talk of the conference. It's going to be a classic, I'm sure. I'd like to welcome Adam Cieplinski. He's going to talk about creating a digital collection of snail hosts for Schistosoma parasites for science and education.
Thank you very much for invitation, and thank you to NASCA for giving me an opportunity to come here for my first ever museum conference, really. It's always been biology or parasitology. So I work with parasites and snails in the Natural History Museum in London, but today I will talk more about our digitization project with snail shells. So, but before I start, I have to tell a little bit about the disease our group work on, which is called Schistosomiasis. And it's a parasitic disease caused by parasite schistosomes. Here is the map, the world map of where it's present. And you can see it's mostly Africa, a little bit South America and the Caribbean, a little bit Southeast Asia. It's actually a very serious disease in terms of parasitic disease. It's only second to malaria. In mortality worldwide. Actually, WHO estimates there's about 300,000 people who die of this disease every year. And unfortunately, it's mostly children, since they have weaker immune system and weaker people. So it's present in around 74 tropical countries. The estimate says about 200, 300 more possibly millions people affected worldwide. So it's a big world effort actually to eliminate it. So a little bit about our life cycle, and so then I can move to the snails really. But I just wanted to have everyone on the same page to explain. So it has a very interesting life cycle actually. The definitive host is a person, a human, or a different mammal, and it depends on the species of the parasite. So different species infect different organisms. The adult worms, which is a pair, male and a female, they live in veins, and the eggs of these worms, they get into freshwater bodies through urine or stool, depending on the species. So it must be freshwater body, lakes or rivers. From the egg hatches the first larva that then seeks for a snail, and it must be a compatible snail. So only specific species or subspecies of snail are compatible with the species of schistosomes. Hence, all the research on snails, that is actually research on schistosome is also research on snails, really. And then from the snail, inside the snail, they multiply asexually, and then the snail releases thousands and thousands of small larvae, which are called cercari. They seek for a definitive host, and they penetrate the skin of the host. So it's enough for a person to enter water bodies, and the parasites basically get through the skin, which they're very small, you can't feel it. So often people get infected and they don't know about that for many, many years. That's why the disease is hidden. It's very difficult to eradicate it. So that's where the snail come from. And my group at the Natural History Museum, the Schistosomiasis working group, we do very different things, really. Different people concentrate on different things. So the big part of the research is the snail surveys, mostly in Africa. We have few African partners where we sample big areas searching for the snails, for the specific species of snails that transmit schistosomes. Diagnostic is a big part of the research. Lots of people are involved in that, and lots of private companies, partners, and so on. And also we have the medical snail facility. So my responsibility is to lead the snail facility. And I'm also involved in some teaching and some more ecological projects as well, and also digitizations, this one. So through our research, as I mentioned, big part of it is the field snail surveys that often are done in a way that you sample huge areas, just like the one shown here. And you rely on the help of lots of people. Very often they are local people. They are obviously not malacologists. They often have no training in biology. So employ lots of people. You train them and give them some tools and ask them to collect the snails, collect sample for specific things that you're interested in. There are many taxonomic keys, obviously, but they are often very scientific. They're very old. They're not very visually attractive. And you can imagine something in a heat, 40 degrees heat by someone who is not a biologist. It's not a very easy task to do. So we were thinking how to And up to date, there is no centralized online database for Schistosomiasis vector snails, or the snails that transmit schistosomes. We were thinking how to use the collection and the Natural History Museum to help those efforts in field surveys, to help the efforts of taxonomy training. So the NHM has a huge collection. It's one of the biggest malacology collection in the world, over 8 million specimens, with contributions by very prominent malacologists. And obviously, our museum, as many other museums, have a big digitization program where different specimens are digitized using different technologies. So we're thinking we can team up with these team and test different technologies to create copies of those shells. So we started looking into David Brown. David Brown was a malacologist working on medical snails. We're looking into this collection. And snail shell is the 3D structure. So I sent here around a few shells that you can have a look at. So they were actually 3D printed. So it's a 3D structure. It's very difficult to represent it on a photograph or in drawings. In some of the keys, obviously, people try to represent the shell by showing it from different angles. That's the best way you can do. So we were testing different approaches for creating the 3D models for digitization. We're playing with laser scanning to then reconstruct the surface, but ultimately we decided on micro-CT, which is, you can do a lot of scanning at the same time, and the resolution is very, very high. So we developed a pipeline where we chose 27 species of African Schistosomiasis vector snail shells out of the collection. We also have a couple of type specimens. Each of those, so we choose one individual per species, and that shell was photographed by our photo unit. Then we scan it using microcomputer tomography. We developed the digital 3D models, and some of those 3D models well then 3D printed. So and you're welcome to have a look at those prints that I show around. So then with all these digital models, we uploaded them on the Sketchfab repository. So for those who don't know, Sketchfab is a free online repository of 3D models. It's used by different organizations, museums, but also computer graphic people, game developers. It's just very easy to use and very, very user-friendly. That's why we chose it. And everyone can have an access, can operate it without any software, really. So it's all nicely cataloged over there. And in the Sketchfab, you can have a look. You can, well, that's supposed to be nice video. Well, okay, it's loaded. So you can have a look at the animation. You can magnify it. You can rotate it, and so on. There are full specimen descriptions. Then those 3D models, they can be embedded in external websites. So this was important for us because we had lots of people working specific groups, subgroups, species complexes of those shells. Then you can easily cut this code, paste it on the website, and you have it in a window, the rotating shell on your website. And then those models can be downloaded. They are all optimized for 3D printing. That was the big part of the project. And there are links to NHM data portal. So you have a 3D model, you go to the data portal, and you have a picture of the real shell and all the necessary information. So the 3D digital models, then we use them for developing few animations. Some of them are very simple, like the one, that one. Some of them are more complex. I'm not sure why they're not loading very fast. They were before. Well, anyway, so some of them are more complex, and the idea behind it was we wanted to develop them for training, for malacology training. So that would be used for people learning about snails in general. But everyone can download our models from online and can make any animations they want, really, using. We use Blender for that, but any software can be used. And then the 3D printed models, which was actually the core thing. Why 3D printed models of shells? Well, they are really great. They are much larger than the real shells. They are very taxonomically informative. So we actually check those 3D printed models. We're looking at them, looking if there are all the features that are important for morphology of a shell are presented on the model. and they are much more robust than real shells. Lots of the shells are very small, they're very fragile. And they're great for teaching. We use them a lot in our outreach events in the museum, like you can see here. We always have those shells because the snails, the real snails, are very, very small. They're around 1 centimeter, sometimes smaller. So whereas with those shells they're really cute. And we printed them in different material to test what will work the best, really. But the idea behind printing is more to use them in a field, really, in a field in Africa, where the main research on Schistosomiasis is taking place, really. So there are those two components of the project. There are those digital models, which only recently were posted on Sketchfab. They can be used for workshops. So we were a bit discussing this kind of possibility of developing a malacology workshop using those models, using the animations. So you have a digital part and you have a 3D printed part. So the idea is that if you're interested in specific species, say 5 species from a place in Africa, you can 3D print them in big numbers, and you can distribute them to people who you work with, asking them to, for instance, search for specific snails, or you can teach children in school. There's lots of outreach activities taking place in schools in Africa with children in area which are endemic to the disease. So this kind of, together with taxonomy keys, together with different visual help, they can be used to help identify species. So, but not also, it's not only this kind of community aspect. They can be also used for science, obviously. So the main kind of morphological approach in malacology recently is basically to take a picture, put few landmarks around, then photograph different shells, different species of variation, and check for the differences. Whereas landmarks apply on 3D model, which has been done for instance, in paleontology. It's not a common technique used in malacology, really, not yet at least. But here we're just playing with simple landmarking. You can see how landmarks on this 3D model of a shell are much better representative of actual shell, or actual shape of a shell, rather than just 7 landmarks here from a recent paper. So we are exploring this using morphometrics of shell for a scientific way. There are also new technologies that we are working on, so a bit discussing. They're called landmark-free morphometrics, when the landmarks are not necessary at all, and there are computer models that compare the shape between each other. So and we're playing with this as well. And those kind of technologies, they can be used for machine learning. They can be automatized pretty easily, and there is more and more research in this avenue as well. So the next steps, what we are doing now, we're playing a little bit with photogrammetry, which is a different way of developing 3D models. It's basically creating a 3D model from photographs that you take of an object, of a shell in this case. It's much cheaper, could be much faster as well than CT scanning. It's often lower quality, but it has a huge potential for automatization, for automatize rather than CT scanning where you need a technician. It costs lots of money. So there's another way for developing those 3D models that we're working on. And we're trying to explore the possibility to link it with a morphometric analysis pipeline. So basically to scan the shell in a field and automatically assign it to species group, for instance. So this is kind of another step. There were also some talks about potential website, maybe application, but that's very preliminary, and we'll see how the project will work. So the Sketchfab catalog has been created very recently, and I hope the paper will be published soon. It's under review right now. So it's just to mention that this kind of projects, they're very collaborative, and I've never worked before with the 3D models in my lab. I'm a freshwater ecologist, so for me it was a very steep learning curve, and I had to learn a lot of things, which is fascinating, and it's more veering into computer game kind of fields, really. But I had to, well, we were working with different people. So with my group, Bonnie Webster, and Emery from Schistosomiasis working group, expert in 3D models animation, Marco, Brett, Bartek, and then a snail taxonomy, John Albert from our collections, and also with people who help me print models, paint them, and so on. So it's kind of really collaborative things. But I think it's very interesting to collaborate with people from different expertise, because you learn a lot, and I learn a lot about 3D modeling and how it works. So that's all basically I wanted to tell you. So this is the barcodes that leads you to the Sketchfab catalog if you want to have a look at the shells yourself. If you have any questions or are interested in a similar projects or similar approaches to your collections, you can write me, and these are my social thingies. And so thank you very much for thank you to my lab, the Schistosomiasis working group, to Wellcome Trusts for sponsoring, for founding this research, and to Natska for inviting me and giving me the opportunity to present the project. Thank you. And yeah, I'm happy to answer any questions.
Anyone have any questions for Adam? Hi, we're thinking of doing something similar with seeds. I wondered, does the specimen get damaged in any way whilst you're scanning it? Do you have to put a pin in it, or how does it do all sides at once without any damage?
So with CT scanning, I think I had a picture of the pipeline. No, it doesn't damage. We all work with dry shells. And basically the way we did it, we tucked them into plastic tubes with kind of styrofoam, and there were CT scans, so it's absolutely, it doesn't damage them. With seeds, I don't know if you can use the mic. I know that we also developed the 3D models from scanning electron microscopy of seeds. It is possible, yeah, but seeds are very, very small. They're much small.
Hi, great talk. Thanks very much for putting it forward. I was wondering if you thought about scanning the trematodes and scaling those up, because communicating life cycles along with hosts can be a really complicated process, but if you can show it, it does a lot of the work for you. Are they too soft-bodied, or do they not scan as well?
Yeah, that's a great question. Yeah, we did. We actually have a model of schistosome pair. I didn't bring it with me because it was not a part of a project. The model has been developed years ago, before my time at the museum, and it was done using confocal microscopy picture, which was then converted into 3D model. So you can't really use micro CT as they're very delicate, and they have to be, you know, suspended in a liquid, which is a bit of a problem for micro CT scanning. But yeah, it is possible. It just requires a bit of fiddling around and playing, and a lot of this kind of 3D modeling skills to make it look nice. Because when you do use confocal microscopy or scanning electron microscopy, then you can often you have to stitch it all together. So I actually finished like a short Blender course to be able to work with those models, to learn how to do it. But it is doable.
Thank you. They're really cool. My question's about general scaling up of objects. And when you're working with, people in the field and school children and people in general that might not know the size of these objects, and as a maker of objects myself, it's always hard to translate that you're scaling something up. Do you have a general rule, as in they're only scaled up to that many times? How do you translate that to the people that you're working with or that they're working with?
That's actually a very good question, because obviously you can print them as big as your printer allows you to. No, we don't. I now know of 2 groups working in Uganda that have some of those models, and I trust in their knowledge, basically. I think the best way to show is to show the real shell, which is often very, very small and then to show the model. That's why I left some of them unpainted, just in white, so you can see it's not a real shell. I think I show one which was painted by our artist, and this looks like a real shell, basically. But I think, you know, yeah, if they're white or any color unpainted, it kind of shows that they are not real.
Okay, I have the most basic question, which is, how do you paint the one that's painted? It looks amazing. Do you do it by hand?
Yeah, well, not me. It was done by Lee Edwards. He's an artist in the museum, and he works with collections, actually. So it's actually a good question. So normally, the easiest way people can 3D print things is just with using the standard cheap plastic. The problem with that is it doesn't really hold paint very well. So the shell I showed, the painted one, has been printed in a very high quality resin, which we noticed it just holds paint better. So yeah, I mean, I guess you can use it. I'm not an artist myself. You need someone with like conservation skills, for instance, to understand how paints work. It's just but yeah, he did it basically well. So I provided him with a picture of the real shell, so he had it on his tablet. Then he had a shell here attached, and he was looking at the picture and painting it as a reference. So it's really, yeah.
Yeah, lots of talent. Okay, thank you so much. Adam, thank you so much. That was great.